Okay, it's time for us to have a look at how can we deploy this system in Huawei Cloud.
There is a complicated graph showing the integrity of the whole architecture of the authentication system of MRS. And basically, the authentication follows quite a lot of processes and steps. As is shown in the slide, step 1 to step 4 correspond to processes of logging in to the manager web UI. And in addition, in the processes of logging into the web UI, a mechanism called CAS, or Central Authentication Service, is used to implement SSO. And this CAS needs to be generated and delivered by KDC, as we mentioned before. After that, step 5 and 6 correspond to processes of logging into the component UI, and step 7 corresponds to access between components. In these several processes, jobs security authentication needs to be provided by Kerberos as well, and LDAP 1 as well as LDAP 2 are deployed to improve reliability. If the OMS or the node where LDAP is deployed in the cluster is faulty, you can still log into Manager to perform basic O&M operations. The two LDAPs are not roles to each other. LDAP 1 as a process is managed by OMS, while LDAP 2 as a component is managed by the cluster. And in this flowchart, we can see a lot of names. Here, Manager means MRS Manager, and Manager WS means MRS Web Browser. And by default, we deploy the system in load sharing mode, which means that by default, there will be at least two sets of LDAP plus Kerberos structure in the system. Like here, we have Kerberos 1 and LDAP 1, as well as Kerberos 2 plus LDAP 2. So Kerberos 1 and LDAP 1 are suggested to be deployed on the management plane in the OMS, while Kerberos 2 and LDAP 2 are deployed in the cluster directly. But the two sets of structures are independent to each other when doing the authentication identity, or namely, process 4.1 and 4.2 are two parallel processes. Okay, so throughout the whole chapter, we are always talking about Kerberos and LDAP, and in last slide, we always consider them together as a whole. But what is the relationship between Kerberos and LDAP, and how do they interact with each other? Just a quick review of their relationships. So basically, Kerberos is the IAM authentication server, which provides unified authentication for all services in the cluster and secondary deployment applications of customers. Meanwhile, LDAP serves as a user's data storage center and stores user information in the cluster, including passwords and supplementary information. During the unified authentication, all data of Kerberos, including user passwords and supplementary information, needs to be obtained from LDAP. Like is shown in the graph, all processes, including reading, writing, and modifying, needs to go through LDAP again and again. What's more, the rights provided by MRS include O&M rights of manager and components. In the actual application, you'll need to assign different rights to each user based on service scenarios. To improve the usability of permission management, MRS Manager introduces roles. You can select specified permissions and assign them to roles in a unified manner. In this way, permissions can be viewed and managed in a centralized manner. After a user is added to a user group to which roles are allocated, the role permissions of the user group are assigned to the user. As for the user data, basically, there are two types of user information. If you are interested in this, please have a check for necessity. And for service authentication in the cluster, the key point here is that LDAP server does not directly interact with other services components except for the Kerberos service. Namely, LDAP serves as the backend for data storage, and Kerberos is the front line who interacts with others directly. Then, in this slide, you can see common role deployment mode for Kerberos and LDAP. For Kerberos, the most important roles are Kerberos server and Kerberos admin. And quite literally, Kerberos server provides authentication services, while Kerberos admin supports all the management works. As for their deployment mode, just as mentioned before, the Kerberos server needs to be deployed in load sharing mode, which means that there should be at least two Kerberos server instances. But moreover, these two Kerberos instances are distributed onto two control nodes so as to improve the reliability of the cluster. And for LDAP server, the service role is called SLAPD server. And actually, SLAPD is just the name of the LDAP process. And for LDAP, they are also deployed in active and standby mode. So again, we need to distribute them onto two different nodes for reliability. Now, let's make a conclusion. As mentioned before, both LDAP and Kerberos need to be deployed onto at least 2 nodes. And we also mentioned that Kerberos needs to connect with LDAP frequently for querying user data. So why not deploy them together? And that is just how to design our deployment mode. We recommend that LDAP server and KRB server in all clusters be deployed on the same node, and active KRB server are deployed together with active LDAP server, while standby KRB server is deployed on the same node as the standby LDAP server. As for the strengths of Kerberos, we mainly introduce the following 4 points. Firstly, Kerberos helps to prevent brute force attacks. In a brute force attack, the attackers tend to use different usernames and passwords to frequently log into the system. But in MRS, Kerberos provides a short-term key as the session key for authentication, and this session key is only valid in one session. Secondly, Kerberos helps to prevent replay attacks. In general, replay attacks are used to send a package that has been received by a destination host to deceive the system. The replay attacks are mainly used in identity authentication and damage the correctness of authentication. The basic principle is to retransmit the previously intercepted data to the recipient. But Kerberos generates the requests encrypted and marked by timestamp, so the normal replay attacks will be identified very easily. Thirdly, Kerberos supports mutual authentication. This is optional and can be configured if needed. If we do not switch on the mutual authentication function, only servers have rights to identify the client. But with the mutual authentication, client is also able to request that the target server verify its own identity. And if mutual authentication is requested, the target server will take the client computer's timestamp from the authenticator, encrypt it with the session key, the TGS provided for client target server messages, and send it to the client. Consequently, a client won't be deceived by some fake servers camouflaged by the hackers. Finally, Kerberos provides reliable performance. This is basically because of the smart design of the architecture, and thus to relieve some of the pressure of the vital components like KDC. Finally, there are some parameters and commands for Kerberos. If you are interested in these parameters and commands, please have a look at the basic description of it. And among all the common commands, the most widely used one is kinit and kadmin, which are used to initiate the Kerberos environment and to do some management work by Kerberos. Alright, that is all for LDAP and Kerberos. In this chapter, we mainly talk about the basic concepts and features of LDAP and Kerberos, and they work together to provide the identity authentication management for Huawei Cloud. Just need to remember, LDAP is a directory service which supports user data storage and management, while Kerberos provides session key generation and authentication services.
Thanks for listening, and hope you enjoy all the contents in this chapter. In the next chapter, we are going to introduce Elasticsearch, which is very much like a Google search in big data.